Hi, in this video, we present a part-based pseudo-label refinement framework for unsupervised person re-identification. Person re-identification, also called person re-ID in short, aims to retrieve a matched person for a given query, across different camera views or timestamps from gallery images. Supervised approaches have achieved impressive progress with the discriminative power of deep neural networks, trained by a large amount of labeled data. However, it demands costly annotations, limiting their practicality in large-scale real-world scenarios. Due to this issue, unsupervised approaches, that learn the discriminative features for person re-ID from unlabeled data, have recently received much attention, and recent methods accomplish this task by using pseudo-labels with clustering. However, inevitable and inherent noise in pseudo-labels significantly deteriorates the performance. To tackle this label noise problem, several pseudo-label refinement methods have been proposed, which utilize predictions from a teacher network as refined pseudo-labels. However, these methods consider only global features, and neglect the fine-grained information from part features, that have demonstrated their effectiveness for person re-identification by several studies. Our key idea is that, this fine-grained information can provide not only useful cues for better representation learning, but also robustness against label noises. With this motivation and idea, we propose a part-based pseudo-label refinement framework. Our framework extracts both global and part features for model training, and it utilizes the complementary relationship between global and part features to refine label noises. Like existing clustering-based methods, we alternate the clustering and training stages. In the clustering stage, we extract global and part features and assign pseudo-labels through global feature clustering. We then compute our proposed cross-agreement scores to utilize a reliable complementary relationship. In the training stage, we mitigate the label noise with the proposed pseudo-label refinement methods based on the cross-agreement score. Agreement-aware label smoothing for part features, and part-guided label refinement for global features. Let's go into more detail. We use complementary relationship between global and part features. However, as shown in the figure, features in the same image can capture very different semantic information due to occlusions or backgrounds. In this case, using complementary relationship naively can result in unreliable information, and identifying whether the given complementary information is reliable is an essential problem. To address this issue, we design a cross-agreement score, which is the Jaccard similarity between the k nearest neighbors of the global and part features. Intuitively, a high cross-agreement score implies that the global and part feature space are highly correlated, and can provide reliable complementary information. On the other hand, a low score implies that two feature spaces are not correlated, which can result in unreliable information. Based on the cross-agreement score, we refine noisy pseudo-labels. Since global feature clustering can neglect the local context of each part, training all part features with the same pseudo-label can be detrimental to model training. To address this issue, we propose agreement-aware label smoothing, which smooths pseudo-labels of each part according to the cross-agreement score. While vanilla label smoothing adjusts the labels for all parts blindly without considering the characteristics of each part, our AALS calibrates pseudo-labels of each part according to cross-agreement scores, leading to reliable part feature learning. For global features, we propose part-guided label refinement, which refines pseudo-labels by aggregating predictions of part features, with different weights depending on each cross-agreement score. With PGLR, global features learn from the ensemble part predictions with rich fine-grained information without additional teacher networks, which is effective and computationally efficient. Finally, the refined labels are used to compute cross-entropy loss on each global and part feature. From now on, we'd like to share some experimental results. First, we analyze the cross-agreement score. We visualize a soft masked image by multiplying the image intensity with the cross-agreements, and thus a low score leads the corresponding part of an image to become dark. Each region of a color jet bar indicates the average score over the entire training epochs. Our cross-agreement scores effectively identify irrelevant parts to a person. We also visualize the topmost part feature space by trained models with and without agreement-aware label smoothing. While the embeddings without AALS blindly overfit to ID labels, our AALS shows reliable embeddings that are well distributed while considering the local context of each part, and achieve proper part representation learning. This is GradCam visualization of the predictions by global features, with and without part-guided label refinement. Without PGLR, it focuses only on the most discriminative parts in the global context, such as a hat, shoes, and a bag. On the other hand, PGLR captures more diverse regions thanks to part-guided refined labels with rich fine-grained information. The proposed PPLR framework also outperforms previous state-of-the-art methods on several benchmarks. Thank you for watching, and for more results and code, please visit our project page.